So before we move on to our new units regarding fractions, we're going to look back at our last time we visited fractions with a do you remember how question. And my question for you on this relates to my cubes that you can see on the screen in front of you. And I'm asking you what fraction of the cubes are red. Is it A, 3/4, B, half, C, 1/4, or D, 2/4? So what fraction of these cubes that you can see are red? A, 3/4, B, half, C, 1/4, or D, 2/4? So work out the answer and come and join me when you're ready. So let's have a look at the strategy where we can use to calculate the answer for this. So our first thing is we've got to work out how many cubes there are altogether. And we can see, looking at our tower of cubes, we have 12 cubes in total. And then we're going to find out how many of those cubes are red. And in this case, out of the 12 cubes, we have 6 of them that are red. Now I know that lots of you will automatically know the answer. 6 out of 12 will give you a fraction. But if we're thinking about this, what we can look at is using our known strategies from previously. So if I'm looking at quarters, I'm chopping them into 4. So if we have 12, we're going to divide 12 by 4, and that's going to give me an answer of 3. And if we want 3/4, then that's going to be 3 lots of 3, which in this case is going to be 9. If we're looking for B, we're going to take our 12 cubes, we're going to chop them into 2 parts. So we're going to divide them by 2, which is going to give us 12 divided by 2, gives us an answer of 6. For C, we have 1/4. So again, we're going to divide those 12 cubes by 4, and 12 divided by 4 gives us an answer of 3. And we've got 1/4, so that's 1 times 3 to give us 3. And for D, we have quarters again, so this is going to be dividing by 4. 12 divided by 4, of course, gave us an answer of 3. 2 lots of 3 to give us 2/4 will give us an answer of 6. So in this instance, we're looking at an answer of B or D. It's half, which is also the same as 2/4. Now in today's sessions, we're going to be looking at this same idea of equivalent fractions, 2 fractions that have a different denominator, which actually mean exactly the same thing. So these are called unlike fractions because they're not going to be using the same denominator. But we're going to be looking at this idea of equivalencies, which means they're going to be the same size. They're going to be exactly the same amount, just said in a slightly different way. So let's open up our textbook and have a look at our first problem. So we can see that our first set of questions are all relating to our running track. And we can see for question 1A, who is correct, Lee or Mr. Lopez? Mr. Lopez is saying, well done, you have run 2/4 of the way. And Lee is telling me that he's run 1/2 of the track. And our question here is, who is correct? Is it Lee or Mr. Lopez? And in order to do this, think about the fractions both of them are using, and then look at the track. How has the track been divided to help you to be able to understand this question? Is there anything that's going to point out that Lee's right? Is there anything that points out Mr. Lopez is right? So for question 1A, who is correct, Lee or Mr. Lopez? For question 1B, what we're asking here is to look at the lines drawn on the track. And you're going to write down 2 or more fractions that are equal to 1/2. So for this question, what I want you to be thinking about is this idea of the tracks, and I want you to think about what markings you can see on those tracks above and below the track that Lee is actually running on. And I want you to think about what they're actually showing and to see whether you can find those equivalent fractions, the idea of fractions which are exactly the same as 1/2. So pause the video, give those both a go. Question 1A, who is correct, Lee or Mr. Lopez? And question 1B, look at the lines drawn on the track and create 2 or more fractions that are equal to 1/2. And then come and join me when you're ready so we can look at the different strategies you've been using. So let's have a look at question 1A. And we were being asked here, who is correct, Lee or Mr. Lopez? Now, Lee has told me that he's run 1/2 of the track, and Mr. Lopez is saying, well done, you've run 2/4 of the track. So what I'm looking at here is Lee correct that he's run 1/2, or is Mr. Lopez correct that he's run 2/4? So in order to answer this question, I've created myself 2 bar models to represent 2 different fractions. So if we look at them both, we can see that each bar is split up into equal parts. So how many parts is the first bar split into? And how many of those parts are shaded? So looking at our first bar, that'll help us identify what fraction is actually being shown. And if we go back to our original image, we can see that that bar model represents the lane that Lee is actually in. So he has a lane that has two equal parts, so my denominator is going to be 2, and he's run one of them. So one of those two parts, or 1/2. Now the bar model below, we can see that this one's been separated into the 4 parts that Mr. Lopez is talking about, and we've coloured in 2 of those 4 parts. So this bottom bar model shows us 2/4, and we can see just by looking at them that 2/4 is exactly the same size as 1/2. So in this instance, Lee is right that he has run 1 out of the 2 equal parts, or 1/2 of the track, and Mr. Lopez is correct by saying that he's run 2 out of the 4 equal parts, 2/4 of the track. Because on this one we can see that though we have different numerators and denominators, they are exactly the same size, which makes them equivalent fractions. So the answer to question 1A, who is correct, is both of them. Lee is correct and Mr. Lopez is. So now let's move on to question 1B. For question 1B, where we're looking at the lines drawn on the track, and we're going to find 2 or more fractions that are equal to 1/2. So again, we can use our bar models to support us with this, just as the running track is showing us. Now we can see on here I've got 4 different bars, and each bar is separated into a different amount of equal parts. The equal parts is really, really important here. I can't just chop it into parts because I fancy it. Each one has to be the same size in order for it to be a fraction. So looking at that top bar, it's split into 2 equal parts because each part has to be worth exactly the same, in this case 1/2. The second bar, the one just underneath it, is shown as the quarters that Mr. Lopez was talking about. And when we look at drawing exactly the same amount as the 1/2 above, we can see that that fits exactly over 2 of those quarters. So as Mr. Lopez said, 2/4 of the track run, which was equivalent or the same as 1/2. So let's see whether we can look at the third bar and think about our eighths. That bar is broken up into 8 equal parts. So that means we're working in eighths, and what we're looking at here is by putting exactly the same size as 1/2 or 2/4 onto that bar model to see how many eighths are the same as 1/2. And we can see that when we put that same shape over the 8th bar model, we can see that 4 eighths fit into that same amount as 1/2. Now looking at my 4th one, we can see that we split it up into more parts, and if we take the same size again as 1/2, we can see a third equivalent fraction. So we started with 1/2, which was the same as 2/4, 2/4, which was the same as 4 eighths. Now looking at our final one, we have another one. So our first thing is to find the denominator, is how many equal parts has that bar been broken into, and then how many of those equal parts have I shaded in order to give me my numerator. So looking at this, have you been able to identify that this one is 8/16? So using our bar model, we can see, because each bar is exactly the same length and divided into those denominators which are equal sizes, 1/2 is the same as 2/4, which is the same as 4 eighths, which is the same as 8/16. And now just out of interest, do you see a pattern within those numbers? So looking at, for example, the denominator, going from 2 to 4, from 4 to 8, and 8 to 16. And do you see a pattern with those numerators? 1 to 2, 2 to 4, 4 to 8. This is another method we can look at to do exactly the same thing. So think about the patterns that you're seeing with these numbers once you've proved it using your bar models. So in answer to question 1B, look at the lines drawn on the track, write 2 or more fractions that are equal to 1/2. Well, we know that 1/2 is the same as 2/4, which was also the same as 4 eighths. And we can also, if we look at that very bottom lane, we can see that it's chopped into 16 parts, and we can work out that it is also the same as 8/16. So using our running track, we can see that 1/2 is the same as 2/4, is the same as 4/8, is the same as 8/16 to answer question 1b. So now we've looked at that first question, you're ready to move on where you're going to be solving all these questions about equivalent fractions. So you're going to be learning to recognize equivalent fractions with small denominators, so that bottom number not being too big, so you can actually see them clearly, and you're going to be using diagrams to represent them, which means that you could be using that bar model. Now, a little tip for you is on the very next question. It starts talking about folding pieces of paper. My little tip to you would be physically get the strip of paper and fold them into those parts. It will really help you to see this idea, and making sure that you're not going to make mistakes by making different parts of that paper slightly different sizes. So actually take a strip and fold it into these parts, and this whole activity will become far simpler for you. So good luck with completing the textbook and then moving on to the workbook, and I look forward to seeing your work on equivalent fractions. Good luck.